So, hello everybody. So yes, I'm going to speak about what is sometimes called modern pandas. Pandas is not so old, but indeed it has a lot of evolutions. And nowadays, the way of using pandas has changed a little bit, especially on the way of writing pipelines and usage of the functions based on Panda. So if I do some kind of spot setting, usually we have several tools to work on data pipelines. Of course, Panda is one of them. But you have also when, for example, your data set is becoming very large, you will sometimes use Dask, which is another option, purely Python option, let's say, or very frequently, people are going to use PySpark as the option for large volumes of data. When your pipelines are very simple, very often it's okay to do it only with Pandas, Dask, or PySpark. But when your data transformation and data processing pipeline is becoming more and more complex with a lot of tasks, with a lot of dependencies between the jobs, then you will very often appreciate to use something more sophisticated for managing these jobs, such things like Airflow and Luigi, which are, let's say, the two most obvious choice for this. Okay. So I'm going to speak here about Pandas, especially on the preparation steps of the data. And I will zoom especially on using method chaining brackets, which is a kind of a joke, and of course lambdas. So most of the comments I will have today are based on general reflection thinking of Tom, who is a contributor to Pandas, and he has wrote several papers and articles, etc., that you can have a look at about how to efficiently use Panda. So here my main focus will be on the method chaining, but you can have a look at the others aspect of his writings. They are quite interesting indeed. So here I'm going to talk mostly about writing data pipeline through chaining functions that are applied to the data set. This is not specific to Pandas. Many other libraries and package and frameworks are using this. You can find this in R with Deepler, for example. Spark also is using this way of writing things quite intensively. And just to give you a very quick look about what it can give you, it's going to be a sequence of functions that are called on a data set that has been read, for example here a CSV file, that will allow us to have one sentence, let's say, a writing of the transformation, rather than using several steps like this. So here it's very basic, but of course you can guess that with a more complex pipeline you will have a lot of steps like this, and you will have to try to find out names for intermediate variables, for example, etc. And so what we are trying to present here is the way of writing a little bit more, let's say, aesthetically, I would say, this kind of transformation. So in Pandas, you have a lot of, well, not a lot, but you have several functions that allows this kind of writing. They are going to provide you features for capabilities for computing new columns, dropping columns row, calling some specific function of yours, renaming columns or the index of the data frame, etc., etc. I'm going to show some of these in action. And so it's some of the evolutions. The latest version of Pandas have tried to ease the way of writing such kind of pipeline. Okay, so I'm going to introduce now some example, of course, to go into more details. I'm going to use, and it's a kind of strange coincidence. I'm going to use a data set that I'm using very often about the price of gas in France. It's a very interesting data set because it's not too big and it has still a lot of data available. And if you go on this website, it's a website that has been created several years ago to foster the competition between gas stations. And you can have on this website all the prices of every gas type in every station in France for the last 10 years, something like that. Okay, and so it gives us a quite large data set on which we can build some kind of some interesting transformation, and also it's not too big, and we can work with it without, as examples, without having to wait too much time in between. And so the original data are in XML file. So in order for easing the end out on such kind of data, I have transformed them into CSV file, and you can download the versions. So in order to avoid any kind of polemic, yes, or fight, I'm not going to use 2018 data. Okay, I'm just going to use 2017 data. The year is not over, and we will see what happened in the coming month. Okay, so just to give you an introduction before moving to the notebook. This is the kind of writing we would like to achieve with this kind of way of writing your pipeline. As you can see, you have steps that clearly appear in your code. They are going to start from reading a file and then moving through different steps where you can have comments, you can have quite a readable expression of your pipeline. And so it's a way to be able to clearly design this kind of pipeline. Okay, so of course, first step is reading the data, then renaming, for example, the column. These are examples I'm going to do to give more examples just after. You can recompute or compute some columns, and of course, for example, you can drop some of these columns. Okay, and in the end, starting from the original data set, which was just right here on the bottom, we end up with something like that. Okay, so no big deal with this one. And what I'm going to do is that I'm going to show this on a notebook. So it's not very good as a contrast. Okay, so is it okay if I move to the dark theme? I guess so. Oops. Is it better for you? I guess. Okay, so everything starts with Pandas, of course. I'm importing the set. Okay, I'm going to zoom a little bit. No, it's a little bit too big. I guess it's better for people in the back. Okay, so I'm reading I'm importing, sorry, the module, Pandas, the package. And then I'm reading few rows just to show you that this is quite a classical CSV file, a French CSV file, let's say, with a semicolon as a separator, and we have no header in this file. And so we will read it more efficiently just after. Okay, so for example, we can read this file. I'm not sure it's good contrast for you, but very sorry for that. So we are reading the file, we are renaming the columns with the function rename, where we can use some dictionary, for example. We are assigning new variables, so I need maybe to explain a little bit. The prices are in 1,000 because it's the law to display 3 digits in France, so the prices are in thousands. So I have to divide, if I wanted to have it in euros, I have to divide it by 1,000. And also the latitude and longitude are expressed in 100,000. And so I need to, if I want to have it as degrees, I need to divide them by the 100,000. And for example, I'm just removing some of the comment. Okay. So in this file, we have something like 3 million rows and just a set of columns. Okay, so we have the station ID, we have the zip code, we have the latitude, the longitude, the date of the prices, the gas type, which is a gasol, super, etc., and the price. Okay, and so we have some info, and we were able during the read file to be able to, let's say, specify that we would like to parse the date and that we would like to keep the zip code, which is the second column, as I need to rerun that, sorry. As a string, okay? So we have another file, which is the station file, that we are also going to use for some examples. In this station file, we have the station ID also, the zip code, latitude, longitude once again, and we have the address of the station with the street name and the city name. Okay, and so we are also using the same kind of writing to get this. Okay. So after, so these are the basic files and basic loading that we can do. I will introduce some of the other features that we can use for writing in such a way, and introduce some of the difficulties we may have by using this way of writing pipelines. So, for example, you know maybe the lock operator in Pandas that allows you to select either the rows or the columns based on here some conditions. And so if I want to see what are the gas stations within Le Kremlin-Bicêtre, I can, for example, say I would like to localize stations which zip code is the value of the zip code in for the Kremlin-Bicêtre. Okay, and so I have only two stations available. As you can see here, I have used the name station DF in my expression, and this is going to be a little bit a problem later, because what I call the reference problem, because when I will add the steps to my data frame, to my data pipeline, of course I will not be able to reference the original data frame for applying some transformation, because of course the latest data frame is not the same than the one I started from. So we have some functions that allows to avoid this kind of problem of using the name. I'm going to show also some issue with that later. You can use the query function, for example, where you don't have to specify the name of the data frame. You just have to specify an expression that is going to be interpreted by Panda and applied to the data frame on which query is applied. And so in this situation, it's quite easy to write your condition as a string, and it's going to be interpreted by Panda. You can also use this kind of trick, which is quite interesting. If you want to have general variables, parameters to your pipeline, you can refer to some external variable that will be interpolated within the string for here the selection, the query. And so you don't have to write directly the values in your expressions. Okay? So we can extend also the usage of lock, not only working on rows like before, but also on columns. I'm very sorry, I'm not sure it's really readable, but... Sorry? You prefer white? Yeah. Turn off the light? I don't know. Yeah, at least you don't see the cells, but at least you see the code. I'm not sure. Okay. Okay, so here I'm using a lock, the same operator than before, but this time I'm using it in both way, I would say, on both axes of the data frame. For selecting rows, here I use a condition that I express this way, and then I can use also a list of fields I would like to keep, for example, in my subtable. And the result is, of course, only selecting the two fields for address and city for the two stations in Le Crémer-Bicêtre. Okay? As you can see here, I didn't use station DF, of course, because, for example, in this expression, I don't know what is station DF. So I need, at that time, to introduce a writing based on lambda. And this is maybe one of the issues, let's say, with this kind of writing, is that you are going to use a lot lambdas. And you know that Guido was not so fond of the way lambdas has been designed. And it's sure that you have, for example, in Scala, much shorter way to express this kind of expressions. And for sure, it could be certainly interesting to have a way of being able to, let's say, have an argument, an argument, yes, that would be the latest result used that we had in the step before, and that we can reuse in this condition. So you have tricks where you are, in a way, shortening the lambda expression just to spare you a few keystrokes. But it's not so, well, you have to live with lambdas in most of the cases. Sorry? Ah, ok, ça sera mieux, ouais, effectivement. Merci. Ok. Oh, ok. Okay. So, you can, of course, also use the brackets, the square brackets, just to select, for example, a set of fields. So you are reading your data, and at some time you read, you keep only the fields you would like to keep in your data frame. Okay, and you have this way a way of making a projection of your table. Okay, of course you can use any trick you would like to use for station here using station header with station header was a list I defined just before. I don't know if you remember. It was there, or it's just the list of the field I would like to have in my station file. Okay. And this way I can, for example, use any kind of expression allowing me to filter and select my list of fields based on the strings of the field, for example, etc. Okay, so these are all the way we can filter the table on the row in both axes, on the row and on the columns. You also have functions called assign in order to compute new columns, and of course here this is the place where we are going to use a lot of lambdas functions. And this is typical where we have the part for reading the file and then the assign part for computing the columns. And sometimes you may have a long list of columns, and here you have a clear definition of each of the columns. So it's, for me, I find this very readable and very easy to comment and to edit. You just have to put a command sign just before if you don't want anymore to compute some variables. So it's it's also very easy to edit. Okay. So about my reference problem I mentioned before, this way of writing has some danger if you don't take attention to this. So for example, here I'm reading the station file, and then I'm doing a query. Okay, selecting only the station in Le Crémer-Bicêtre, but after I'm reusing the name station file in this chaining. And at that time, it's going to work, of course. I have no error if I run this. Okay, but of course it's wrong. Why is it wrong? It's wrong because, for example, if I do some changes on the zip code just before, since I'm referring to station DF, of course I'm referring to the original data frame that has been read here, and thus here I don't have the right answer in my department column. So you need to be careful about that, because when you have very long chain of functions, of course, well, if you are reusing these names, you are not sure. Well, you need to make sure that you are using the right function. So that's why very often, well, by default, it's better to use a lambda expression in this place, so that you are sure that you are using the latest data frame resulting from the previous function call. Okay. So this one is similar. Okay. So now we are going to do something a little bit more interesting and showing, I expect, I hope, a little bit more the efficiency of this way of writing. So I'm just going to show some graph where I would like to, for example, display the gas price variation over the year, week by week. So as you can see, I can use my original data frame I read before, where I have the prices for all the gas every day in every station of France, something like 3.8 million rows. And so I'm going first to get rid of some of the rows where the date is a missing value. So I can use the drop in A function, and then the resulting data frame, the filtered data frame, is going to be grouped by on the gas type, and I'm using some of the nice grouper function of Pandas, where, for example, I can say I would like you to group the date in my data frame on a weekly basis. So I have several ways of expressing the kind of grouping function I would like to apply, and I'm going to use then the price, compute the mean of the price. So it's going to be the mean of the price per gas price per week, and unstack this so that I have each of the gas type is going to be one column in my data frame, and just plot the result here, and so we get something quite easily. So if you are used to work with Pandas for doing some data exploration, then you can see that it's very interesting to have it this way. Okay. So we see that we think that it's quite pretty stable, but in fact it's due to the fact that we have some kind of gas type here that are where the price is regulated, and so they are somehow squeezing, well, not squeezing, but they are somehow leveling the y-axis. And so I would like to get rid of this gas without, for example, just saying I want to get rid of GPL, for example. So what I'm going to do is that I'm going to use something a little bit more sophisticated. I'm going to, for example, reuse my lock feature here, function, to select, for example, the gas type that are the more present within my data set. Because in fact these gas are very special, and they are not distributed in every station in France, so it's a kind of special case I would like to get rid of. And so here you have the kind of expression that is very interesting for when using Pandas this way, is where you are going to take your data set, filter the missing value, and then within this chain you will be able to express a specific computation based on the original data frame, and then, for example, select only the top 5 gas that are the most represented within France. Okay, and then you redo the calculation, and you can see that it gives you some kind of more interesting graph. Okay. Okay. So now I'm going to move to other other aspect of the of these pipelines. I'm not sure if everybody is really caring about this kind of problems, but as we are developing more and more pipelines, we have the issue of controlling the quality and the results. Very often in the data science community, it's not always a good reflex. Well, it's not an obvious reflex for people to check and verify and test what they are writing, okay? And so you have few options here that will help in doing this. For example, you have a module that is called Vanguard that we are using quite frequently, which is quite interesting in the sense that it will allow us to put within your code some check. So it's a set of functions that are controlling some conditions on your data frame, and it's available as function or as a decorator if you are using them on functions. And for example, you have a function, yes, checking the shape of your data frame. You know that if you are reading some CSV file, due to the unstructured nature of the CSV file, maybe sometimes if someone is adding a new feature or new variable, you will not be able to control that quite easily, and so you would like maybe to check the shape of your data frame, for example, checking the number of rows. And the function shape is a shape, it's checking the number of rows, and if you don't want to check the number of rows, you put none or -1 in Vanguard, and you can specify the number of columns you do expect. So for example, here in this situation, I can take my data frame and pipe the call to the function is a shape, saying that I do expect to have 7 rows in my data frame. So of course, if I run this, it's going to work if I have the right number of rows. But if I change the number of rows, of course, I will have an assertion error explaining me that I do expect to have this shape, and indeed, in fact, I have this shape, okay? So, I'm going just to put it correctly. As you can see, there is a function in Pandas called pipe that allows me to use my own function. Here, I use checks from is a shape from Vanguard, and but I can also use some hack like defining a new method directly on the data frame, Pandas data frame. So you may appreciate or not this way of doing things, but it allows us to write quite nicely that we would like, for example, to check station df if the shape is having 8 columns and possibly writing the data pipeline the same way we were used to. So here in this situation, there is 7 columns, so it's going to fail the assertion. Okay, and if you want to introduce this into your pipeline, it's very easy to, for example, have this check right in the middle of your processing, just after, for example, reading the file, to make sure that you have the right number of column, and then you go on with your process. So. If you go to the documentation of Vanguard, you will see that there are several functions that are available. You can check the shape. You can check if there is values in some columns. You can check if your index, data frame index, has a unique feature, has unique values. within range, within set, etc. So you have a set of functions that allows you to check if everything is okay with your data frame. The last step I wanted to introduce is about logging and debugging, because of course, if you write several steps like this, your chains can be very long, and of course, it's maybe a little bit painful to debug. One of the obvious options is to define your logging function, and of course using the logging module, so that you are able to insert, like I did for the NGuard functions, you can insert your log call directly within your framework, and so generate the log information you would like to have in your call. Okay, so I'm done with this. As a conclusion, we are using a lot this way of writing. I find it quite easy to read and easy to manage. Of course, it has some drawbacks. You end up writing a lot of lambdas, and when you want to do something quite sophisticated on 2 or several columns of your data frame, you have lambdas of lambdas that are that you need to write. So it's not the most easiest way to write things, but at least it's very easy to see all the steps of your data preparation, and it's also very easy to comment out part of it, so that you comment some part of your processing. Thank you for listening, and if you have some questions.
Thank you, Hervé. We'll have some time for questions now.
Thank you for your talk. When you are preparing data, we also do some join or merge between several data frames. Is there a way to use a pipeline with several data frames?
Yeah, I didn't show that because I was not sure about the timing. But there is no issue with using here a merge command, a merge function, sorry. And within this merge, by the way the API of Pandas is designed, it's going to merge your data frame as it's arriving here with the data frame you are specifying here. So it even allows to have a very nice writing where you have your main data frames, and within the merge arguments here, you can write some kind of nice pipeline also for preparing the data. For example, you would like to merge. So we are very often using this in order to have everything contained within the same pipeline.
Is there a difference in performance when you change the operations, or if you write line by line? In terms of memory?
Yeah, it's a good question. No, there is no difference in performance by doing this step by step. The only comment we have sometimes is about maybe you know that in Pandas you may have in some functions an operator called an argument called in place, where the things is done within the data frame. So on some functions, using in place is going to give you better performance in terms of memory size, of course. But, and this is a well-known mention of that, you are not sure when you use in place in every function where in place is available that no copy is going to be done. So in the end, if the in place argument is still doing a copy of your data frame, you will have the same memory footprint on your data pipeline.
So my question is also for the organizer. Will it be possible to have access to the presentation and the notebooks on the website
for sure,
of the
no problem.
conference?
Is it on a GitHub repository?
Yeah, I will push the latest version.
Is it in your presentation?
Sorry?
Is it in your in the presentation?
Yes, you mean the name
GitHub,
of the GitHub?
yeah.
Yes, it is. Yeah. At the beginning.
We have time for one more question, if need be.
In your practice, is there a preferred way of ordering the transformations? Do you usually, do all the locks and then all the groups and stuff?
Well, you all know that the most obvious way of doing things is just to try to get rid of as much as possible as columns and as rows. So every operation that is filtering some columns or is filtering some rows, since it's going to reduce the footprint of your table, must be moved to the top. I mentioned that because obviously it's not that obvious. I still see some code written where a lot of operations are done on rows and columns that are going to be discarded after. So move first everything that will reduce the footprint of the data frame, and then after compute what you need to compute.
If you have any more questions, please take them down and discuss them during the short break after the next presentation. Thank you again.